Here we have a sample problem that says a population of 15,000 has 12,000 individuals who can roll their tongues. If tongue rolling is an autosomal dominant trait, how many people are heterozygotes? So, what we're being asked to figure out is the number of heterozygotes in this population. If we assume that this is in Hardy-Weinberg equilibrium, which we can, we know a couple of things right off the bat. We know that P plus Q is equal to 1. We know that P squared plus 2PQ plus Q squared is also equal to 1. Now, between these two formulas, what we're given information on is we're given information on the second formula. We are told that of a population of 15,000, 12,000 are tongue rollers, and tongue rolling is the dominant trait. So we know that 12,000 of 15,000 is equal to P squared plus 2PQ. And that is going to be a frequency of 0.80 or 80%. Now, that in and of itself is not super useful to us because we can't actually figure information out from the P squared plus 2PQ. But what's also implied in there is the Q squared. The Q squared is equal to all of the other individuals. So that's 3,000 out of 15,000. And that is a frequency of 0.20. So what we've been told in this question is that Q squared is equal to 0.20. Now, a really common mistake that some people will make with this question is they'll take that as, okay, this is the value of Q, but it's not the value of Q. We are always trying to find the frequency of the recessive allele first, because that is the most important thing. But remember, this is Q squared. So Q is actually going to be equal to the square root of 0.20. If we plug that into our calculators, that is approximately 0.45. The actual number has many more decimal places than that, but I'm just going to round it off to 2 decimal places because that's what we record on the diploma. Remember, when you do the calculations, though, make sure you use the full number in your calculator, not the rounded number. So if we know that Q is about 0.45, we also know what P is. P is about 55 hundredths. So about 45% of the alleles in this population are recessive, and about 55% of them are dominant. Okay, now we want to know what proportion are the heterozygotes, and the heterozygotes are the 2PQ. Now, the 2 is in front because there's actually 2 ways to become heterozygous. Get the recessive from your mother or get the recessive from your father. And it doesn't matter which. They are genetically equal. So remember that you have to double it, not just multiply the 2 of them together. So 2PQ will be equal to 2 times 0.45 times 0.55. Remember, though, use the unrounded numbers that are in your calculator. Don't use the rounded numbers. Here, you'll get a slightly different answer, and that can be enough to throw your final answer off, especially with this question. This gives us a proportion of about 0.49. So just under half of the individuals in this population are heterozygotes. If we want to know what that total number is, we are going to take our 0.49, and it's actually 4427 after that, and multiply it by 15,000. So we've got about 7,416 heterozygotes. Now we would probably round this to 7,400 or 7,420. There is still a decimal place that's after this, so it's not going to be a perfect number, but that's going to be pretty darn close. So we know that there's 7,416 or 7,417 heterozygotes in this particular population.